No. Okay. All right. So we're moving ahead here to the product rule because we have things like this. We have this function f of x. It's 3x minus 5 times 4x squared plus 7, and we could FOIL this together, right? Obviously, we can FOIL this together. If we were to FOIL this together, we'd have, the 12x cubed minus a 20x squared plus 21x minus 35. Okay? Now, question. What is f prime of x if you use this FOILed out one? You guys are pretty good at this point.
36x squared minus 40x plus 21.
All right, good. 36x squared minus 40x plus 21. All right? Now, if you have a situation where you're able to FOIL it together, then you're more than welcome to do that, okay? However, we won't always have ones like that. We'll have ones where you might have a 3x minus 5 times a square root of 4x squared plus 7. And you've got to be able to handle ones like this, okay? Now, I start with one that we could FOIL just to know what our answer should be. But I also want to address kind of a common misconception, because here's what a lot of students will do. They'll say, okay, well, I know I need a derivative here, so let's try the derivative of the first factor. What's the derivative of 3x minus 5? 3, okay? It's a linear, so it's just our slope, 3. Okay? Then what's the derivative of 4x squared plus 7?
8x.
8x. And that's a 0, so 8x. So according to this logic, one tendency students have is they just take the derivative of one, the derivative of the other, and they multiply them together. 3 times 8x, and they want to make the derivative equal to 24x, which obviously, as you can see, is not correct. Okay? So, this is one where, if you remember the theorems we learned for limits, we had the limit of a sum was the sum of the limits, and we had the limit of a constant multiple is the constant times the limit, but you couldn't do the limit of a function times another function and just take the limit of each one separately and multiply those together. It didn't work that way. Well, that's why it doesn't work for derivatives either, because remember, derivatives are just big limits. Okay? So, this is what brings us to the product rule. We have to have some way to handle a situation like this, whether we can FOIL it or not. Okay? So let's look at what we would do with this. Okay? Here it says we have these two functions, u of x and v of x. And I know u and v kind of look alike if you're writing a little sloppy, so be very, very careful. But we're going to stick with using u and v because everybody uses u and v, so get used to seeing it. But we have these two functions of x, and f of x is u of x times v of x. Okay? Here's our v. Okay? What this says is that the derivative of the function that's made of a product of two others is u prime of x times v of x plus u of x times v prime of x. Okay? A lot of times what we'll do to help us memorize it a little easier is to leave out the of x parts. We'll say u prime v plus u v prime. Okay? Now notice here, we're still involving those original factors and the derivatives. Okay, so just like the chain rule, you had to multiply, you had part of the original inner function still part of your answer at the end. here you're going to have the two factors still part of your answer at the end. Okay? Now, you see here as well, if it's written as in terms of y, we have the dy dx. It's du dx times v plus u times dv dx. Okay? These are saying the same thing, just different notation. And by the way, this is the notation used on the formula booklet. Okay? So get used to seeing it both ways. Okay? So, how would this apply then to the situation we were just dealing with? Okay? Let's check this out. Okay? First of all, I need to identify the two functions that I'm multiplying. Okay? So one of those is the 3x minus 5. And the other one, the second one, is the 4x squared plus 7. Okay? Now, we already on the previous slide here said what these derivatives are. Okay? U prime, the derivative of 3x minus 5 is just 3. And v prime, the derivative of 4x squared plus 7, is the 8x. Okay? So, now when we put this together, we're going to need all four of these to construct our answer. Okay? So f prime of x is u prime, which was 3, times v, which was 4x squared plus 7, plus u, 3x minus 5, times v prime, which is 8x. Okay?
It works.
And there's our derivative. Now, for this, you should simplify, okay? You don't have to FOIL out extreme things, but with this, it's just a simple matter of distributing and combining like terms. So you do need to simplify this, okay? We have a 12x squared plus a 21 plus a 24x squared minus a 40x. And if we put everything that's alike together, we've got a 36x squared minus 40x plus 21. Okay? Which, if you recall, is the same thing that we got when we FOILed and did it. Okay? So we know it works, at least for this one. Okay? So, identify the two factors, find the derivative of each factor, and then it's just plugging it into the formula and simplifying. U prime v plus uv prime. Okay, any questions so far? Okay, let's see how you guys do with this one. Here's another one that we could FOIL it together if we wanted, but go ahead and see if you can get this one on your own.
Is this right? And also, what time do we leave in 2 days?
I don't remember when you leave.
For tea, okay.
It's just, yeah, no,
With maybe,
it's like when the bell rings, like that's when it officially starts.
because I think we're gonna be going through pictures that are like that.
Did you treat it like they were friends? Did you force
Yeah,
that?
yeah.
Okay, just making sure. Just be careful with those, cause it's easy to,
Yeah, that's right. Yeah, that's it.
okay, you got the same thing. Okay, so we make U this first factor, right? So what's U prime?
6x plus 5.
Alright, 6x plus 5. Okay, and then we have V, which is the 4x cubed minus 2.
4x squared.
Alright, so the derivative is 12x squared. Now it's just a matter of carefully multiplying it all together. Okay? So, U prime V. My iPad had a call.
Oh.
Okay.
Maybe on Facebook or.
I think it was FaceTime. Yeah, it's my sister now trying to FaceTime.
Okay.
My in-laws came in town yesterday, so she might be
Asking
trying to
about that.
contact them.
Okay.
Alright, anyways.
Introduce
Weird.
us to her.
Alright, U prime V, 4x cubed minus 2. And then U plus U, so we've got the 3x squared plus 5x minus 7 times V prime. V prime is the 12x squared. Okay? Now, I know you guys know how to FOIL and combine like terms, so we'll just give the final answer here. What is our final answer?
60x, so 4.
Minus 80x to the third.
No,
Minus
I got plus 80x.
So that's
plus 80x to the third.
So the third plus 84x squared minus 12x minus 10.
Minus 10.
I got minus 84.
I got minus 84 squared.
Yeah, me too. Oh.
Let's see, where do our x squareds come from? They come from,
It's negative
wait,
7.
negative 84x.
It's negative 7 times 12x squared.
Yeah, so that'd be a minus. Okay. Alright, there we go. Alright, see ya.
That's right.
Okay? Does that make sense? Right? Alright. Now, remember what I told you guys last week. I want you to be able to do these polynomials and stuff in your sleep. Because if you're struggling with those, obviously, we're going to be doing a lot of these. Even the chain rule, we're going to do ones where you have to do the chain rule within the product rule. Okay? Actually, I think my next one might even, yeah. Okay?
Hi.
Transition. Bye. Here we have one where we have a u of x that is the x squared, and the v is this whole thing, x squared minus 2x to the 4th power. Okay? So we can't forget about the chain rule as we're doing u prime and v prime. Okay? Now u prime is easy, that's just a 2x. But for v prime, now we're having to think in terms of inner function, outer function, and so on. Okay? So we have here 4 times x squared minus 2x to the third. There's the dy du. The derivative of the outer function, something to the fourth power, is 4 something to the third. But then we have to multiply that by the derivative of the inner function. The inner function here being x squared minus 2x. So the derivative is 2x minus 2. Okay? Does this make sense? Now the cool thing about this is that simplifying it actually is not quite as hard as it may look. All right, let's write this out. dy dx is u prime times v. V is the whole x squared minus 2x to the fourth plus u x squared v prime. Well, v prime is this whole mess here. Okay? 4 times x squared minus 2x cubed times 2x minus 2. Now, there's a reason why I haven't simplified anything yet. Okay? And that is, if you look closely, you'll actually see some common factors that make simplifying this one easier.
2.
Okay? There's a 2, there's an x, and there's also, see, here's a 2x, here's an x, there's a 2 in there. There's also, look at this, an x squared minus 2x to the third power. So watch what happens. If I pull all of those out, I'm going to pull out a 2x times x squared minus 2x to the third power. Then look at what's left over. All that's left of this first term is one of the x squared minus 2x's. Because I took 3 of them out. And I took the 2 and the x out. And then here, I have an x and a 2 left over. I also have the 2x minus 2 left over. But all 3 of these were taken out. Okay? Now notice here, I don't even have to FOIL inside of this in order to simplify. I'm just distributing and combining like terms. Okay? So I have 2x times x squared minus 2x to the third. And then in here, I have an x squared plus, I distribute, that's a 4x squared. So that's a 5x squared. And then I have a minus 2x minus another 4x. So that's a minus 6x. And there we have it. Okay? We could simplify a little bit more. We could distribute the 2x. Or if you wanted to simplify by pulling the x out of the second set of parentheses, you could do that as well, but
Can you just take out the x, like 1x from 1? It would be 2 times question.
Well, then you could just multiply 2x times like the x squared minus 2x and then FOIL that answer. Oh no.
yeah, you can't distribute the 2x in when there's a cube there, but we could distribute the 2x into the other set of parentheses. Make this an x squared minus 2x cubed times a 10x cubed minus 12x squared. Okay, I'm running out of room here. I have to move it over a tad. Okay? So, the chain rule will often apply here, but pretty much any time you use the chain rule, you're going to have something like this where you can factor it out and it makes simplifying easier. Okay, and I would like you to do that. Let's look at one other like this.
So could you leave it like that?
Like this?
Yeah.
Yeah, you would just, you don't FOIL that whole thing out.
Okay.
Yeah, don't FOIL the whole thing out. If we're going to do that, then we might as well have just FOILed it from the beginning and, you know, so. Okay, let's do another one like this, all right? Let me pull these down a little bit. A little bit more room. Okay.
There we go. Okay.
So use the root x. V is the 2x plus 1 cubed. All right. So what's u prime?
1/2 x.
1/2 x to the
-1/2.
good negative 1/2. Okay. What's v prime?
3 times 2x.
3 times 2x plus 1 to the
Second.
second
Times 2.
times 2. Good. Times.
Why is it the times 2 again?
Can you explain? Somebody?
Well, you have to do the outer
The outer.
times the inner. And like the inner would be 2, it would just be 2, right?
Yeah. The derivative of the inner function, the derivative of 2x plus 1 is just a 2.
Okay.
Okay?
So you just add that on.
Yeah, multiply that on here. We take something cubed, the derivative is 3 something squared,
Okay.
and then you take a derivative of that something.
Okay, makes sense.
And I would simplify this, just down to 6 times 2x plus 1 squared. Okay? So now we have everything that we need, we just have to put it together. Okay? Why don't you try to take it from there, see if you can put it all together the right way.
So if we have that answer, we don't have to simplify it anymore.
This can actually simplify a little more. if you distribute this, you'll actually get an x to the 1/2 plus 1/2 x to the negative 1/2.
Couldn't you factor the x to 1/2 in the beginning though?
You can, but you have to be real careful because this is an
Yeah,
x to
so
the
you
negative
put
1/2.
X to negative 1.
Yeah, it would be x to the negative 1. And that's where your final answer may look a slightly different depending on how you simplify.
Okay.
Okay? But here, once we do this, once we distribute, we'll have a 7x to the 1/2 plus, we can make this a 1/2 root x. Okay? Times 2x plus 1 squared.
Yeah, like when I did it here, like I just did 6 times radical x.
Mhm.
Like, is that okay? And like
Yeah.
I was gonna do 1/2 over radical x, but I didn't know if I should have done that.
Yeah, you can. You can.
So like, on a, like
Um,
if I left it like this, would I get points or no?
well, you'll get most of it, but like here, if you see something that you can just distribute,
Okay.
go ahead and distribute, okay? If you're having to do like a 2x plus 1 cubed, or,
Okay.
you don't need to cube the whole thing out, but yeah, if you see a situation like this where you can distribute that in, then go ahead and distribute that in, okay? Now what Derek said was you can take out an x to the 1/2 up here, okay? And what that would do, pick a different color here. Let's go with that, okay? If I took out the x to the 1/2, I would have a square root of x times 2x plus 1 squared. But then in the brackets, what I'd have left over would be a 1/2 x to the negative 1 times 2x plus 1 plus 6. Okay? Then what happens is when you distribute, again, you would still want to distribute here, but you have the root x, 2x plus 1 squared times, this is going to be just 1,
Yeah.
okay? 1 plus 6, you'll have the 7, plus 1/2x, okay? This answer right here is equivalent to this answer right here. They're the same, it's just here it's like we have the root x distributed in, okay? But either one would be valid. Alright? Any questions here? I know it's a lot to remember. There's a lot of little nuances to everything that you gotta do to keep straight. That's why, guys, for right now, take the time to just write down your u prime and v prime. You'll get to the point where you can just plug it straight into the formula and be doing the u prime and v prime in your head. Okay? We're not there yet, I don't think. But eventually you'll get to that point. But right now, take the time to write those down so you can really easily see it. And honestly, doing that will also help you maximize your points if you do make some kind of a mistake later on, like with the IB mark schemes. I know a lot of times what they'll do is, this will be an accuracy point, this will be an accuracy point, using the formula would be a method point, okay? Plugging everything in correctly would be 1 or 2 accuracy points, most likely, and then simplifying it would be like, honestly, this one would probably be a show that the derivative equals this. So, clear working towards the end would be another accuracy point or something like that. Okay. So, just showing this can get you some points. Just writing down the product rule that you're using can get you some points as well, even if you happen to make a little mistake in the simplifying.
Why do they make it so it's like show this instead of just find an answer, like just to make it easier?
Well, they usually will do that because usually this would be like the first step in the problem, and then this is like maybe a formula for the movement of some object, and then they want you to use the derivative for the next like part B or C or D. But if you mess this up, then they're going to have to be trying to figure out follow through points the whole rest of the way. So it really just simplifies everything
Okay.
for you as well, because
Yeah,
if you
it's
get the
much
wrong
easier.
thing, it could make the rest of the steps really a lot more complicated than they're supposed to be. So,
I don't know if this question was asked, but is any part of the exam multiple choice or is it all free response?
it's all free response. Yeah, there's no multiple choice at all on the IB exam. Okay. Alright, so we're gonna stop there with what we've got for today.